can see that. So please go ahead.
Yes, just a second.
Thanks.
Okay. Yeah, so first of all, thanks for the invitation. I'm very excited to be part of this panel and already some interesting talks. So my name is Jonas Jørgensen. I'm an associate professor at the STU Soft Robotics Research Lab. And just as a kind of a segue into the talk, I want to start by noting that when we talk about embodied intelligence, we usually refer to this view of intelligence as emergent from a robot's interaction with its own environment and the task performed. But in this talk, I want to suggest a kind of a shift in perspective. So instead of focusing on the robot's embodied intelligence, I want to talk about the embodied sensuous meaning making that happens when a human encounters a robot. So as a declaration of content, so the two main sort of proposals I'll be making in this talk is that in addition to the hard sciences, aesthetic perspectives can also generate important insights about soft robotics, which is the area that I'm working with. And that these insights might prove essential if we want to have soft robotics technology successfully transition from basic research into real-world applications. So I'll start by presenting some of the background of our research program on soft robot aesthetics, and then I'll transition into introducing two examples of this work that illustrates some of these points in practice. So I'll like to start with the notion of embodied knowledge, which I think can function as a bridge to introduce the kind of thinking that underlies our work. So this is a concept that goes back to philosopher Maurice Merleau-Ponty's phenomenology, and I've included here a formulation from philosopher Mark Johnson. So he defines embodied knowledge as an understanding of knowledge that emphasizes the non-propositional and reflective dimensions of meaning, which arise in spatiotemporal orientations, perceptual interactions, and bodily movements. So what Johnson is referring to here is a type of knowledge that we might have in our bodies that is different from the kind of knowledge we can articulate in words or formalize in equations, for instance. And as Johnson also hints, this type of knowledge is intimately tied to sense perception and bodily sensations. So it is also pre-reflective in the sense that it occurs prior to our conscious reflection. And in our work, we also refer to this type of bodily knowledge and cognition through the concept of aesthetics. And you might be familiar with the word aesthetics from its everyday use as relating to something that is perhaps beautiful or well-designed. But within philosophy, aesthetics refers to a specific subdiscipline that is concerned with art and with sensation. And I refer here to the theoretical tradition started by German philosopher Alexander Baumgarten, who coined the word aesthetics from the Greek word aistasis, which originally referred to also sense perception and sense making. So aesthetic has to do with a kind of non-conceptual knowledge that can be obtained through the senses. And it is something that can be interrogated specifically also within art making practices. So what does all this have to do with soft robotics? Well, in my work, I've over the past 9 years been developing this specific research approach based in aesthetics to interrogate soft robotics from an aesthetic perspective. So it's a work that occupies itself with the aesthetic design, but also the aesthetic reception of soft robots. So it engages with not just the visual design, but also other sensuous qualities that are tied to soft robotics technology, such as tactility and movement, for instance. And it's a kind of very interdisciplinary project that combines different disciplines, some of which I've listed here. And I'll show you just two brief examples of this work that in different ways can illustrate some of its core interests. So the first example is from some work that we did a few years back. And the background is of this work is that we know from research on human-robot interaction that a robot's appearance and its embodiment can actually have a great influence on a number of factors that enter into human-robot interaction. So these include, for instance, the joint task performance, but also the human's perception of the robot's abilities, for instance, and also what types of interactions that actually emerge in the relation between the human and the robot. It's also very obvious that that soft robots, they look very different and they have a different kind of embodiment than traditional robots. So we also need to study this specifically in relation to soft robots. So the background of this work was that we were interested to explore how people actually perceive soft robots and how the impression that they leave modulates the interaction that people have with them. And also, of course, we were interested in comparing with traditional robots, like, is there a difference in just based on these aesthetic aspects of soft robotics in relation to what types of expectations or impressions that people form in the interaction. So to study this, we designed these 3 robots that you see here. Yes, and we did a between subject study with 3 conditions that corresponded to exposure to one of these robots. And as you might be able to see, 2 of them are these soft robotic tentacles, the red robot and the blue robot. And then we also have a traditional robot morphology based on this string of servo motors that is intended to function as a kind of baseline for comparison. So all the robots were programmed identically, and the conditions of interaction were identical. And then we used a number of different instruments post-interaction to assess people's experience of the interaction. And we also video recorded the interactions. But here I'll just limit the focus to one of these. So one of the things we did is that we actually asked people to write up to 5 adjectives that describe the appearance of the robot. And then we got a lot of words, and then subsequently we used text mining tools to extract the sentiment for each participant and calculate an overall valence score. And if we look at the results, then we get these distributions for the words that were used on these 3 different robots. And the distributions, interestingly, appear quite similar for the 2 soft robots. So both of them, they had a slightly higher proportion of positive than negative valence. And interestingly, they also have disgust and joy and anticipation as the most prevalent emotional components. And if we compare to the traditional robot, then we see that it's a lot more level. And here we actually have a higher proportion of negative assessments than positive. And in statistical analysis, we also confirmed that there was, in fact, a significant difference between the soft robots and the rigid robot, and a trend level significant difference for the other one, which indicates that a more positive impression was formed in the meeting with the soft robots. And that's, of course, quite interesting. I think that based on how people experience the robot, they also come to different evaluations. Also, these spiking in disgust and joy and anticipation, I think they're quite interesting, and something that is might be worth taking into account when we develop human-centered applications for soft robots. Because there might be something in this very biological appearance of soft robots that is both to some extent enjoyable, but also can be uncanny. And this perhaps we can mitigate through adjusting our designs. So the second example I'll show is a bit different in the sense that it sort of is intended to illustrate how aesthetic practices and engagement with soft robotics technology can also contribute to inventing other types of robots than the ones that we currently have, and also novel types of interactions or nonverbal communication behaviors between humans and robots. So this is work of my former PhD student, Mads Bjerg Christiansen, and with him we developed this very simple technique to attain dynamic color change in pneumatics-based, silicone-based soft robotics. So the idea is that we have this layered sandwich structure, and then we have 2 different colors on each layer. And then we fine-tune the concentration of the pigment in the top layer so that when it undergoes a strain, it gradually attains more transparency and the underlying color becomes visible. And Mads, he used this technique to develop 2 different prototypes that were inspired by this phenomenon of aposematic coloration that exists in nature. So basically, the idea is that in nature there are certain combinations of color that function as a kind of warning coloration that animals and plants use to deter predators. And we speculated if we could also use this type of warning coloration to guide the interaction between humans and robots. So the idea is that by attaining an aposematic coloration or switching to an aposematic coloration, the robot should basically signal to the user that interaction is discouraged, which might be relevant in different parts of the interaction. So Massey developed these 2 different prototypes. So the first you see here is inspired by skin, human skin or pig skin, and it uses the technology to change from this skin-like variegated color to a kind of reddish bruise. And the second one was instead inspired by sea anemones and brain corals, and it uses this change from being mostly a yellow color to becoming yellow and black, which is a combination that is seen often in for instance, wasps and other animals in nature to deter other animals. And we also did a study that showed that to some extent these kind of signaling were understood by people, but that they were not unequivocal, so they might need to be combined with other signaling modalities to function efficiently. So as time is almost up for me, I'll just jump to the conclusion. So in this short talk, I've tried to illustrate how we can approach soft robotics through aesthetics. And soft robotics as an aesthetic medium, I've shown how it can afford novel types of embodied interaction. And this also shows that softness can actually become active in very different ways. So it can be made to do different things depending on whether we actually use this ability of the robot within a natural environment or a social interaction, for instance. So soft robots, they have these capacities that are tied to their softness. And as I've tried to illustrate, we cannot just reduce them to this mechanical functioning, but when we have humans in the loop, we also need to consider these aesthetic and communicative and relational aspects of softness that also can emerge. Thank you.